Right, there we got matrix and row equivalent operations. You gotta hang in there with me today. First time we've done matrices, so there's gonna be a few words here on the first slide, next slide, and then only doing one long example, so you gotta hang in there when we get to that. All right, a few words here that you really need to know. First one is just what a matrix is. A matrix is just a rectangular array of numbers. There's one right there. There's one down here. Those are what a matrix looks like. Dimensions. Dimensions of a matrix, or sometimes called order of a matrix, are how many rows it has by how many columns. So this one up here is a 2 by 3 because it has 2 rows going across and it's got 3 columns coming down. So it's a 2 by 3. The one down here on the bottom is a 2 by 2 because it's got 2 rows and 2 columns. Remember, it's rows first, columns second. An augmented matrix is where they take a system like this one right here. They took that system of equations and put it all inside a matrix. If you notice, all the variables are missing, and they put a little line or broken line where the equal sign was to kind of separate right there. So that's called an augmented matrix, and that's what we're going to work with today. The main diagonal is starts at the top left. So I put 2, 4 here because 2 and 4 in the main diagonal in both of those. And there's a matrix called a coefficient matrix, which just has coefficients only. So the 2, the -3, the 1, and the 4 is a coefficient matrix, not the augmented like up there, because that one also has the constants. So just the coefficients only. All right, we're about to do something called Gaussian elimination. And there's 3 rules for Gaussian elimination, and we need to make sure we do these right or know what they are. The first one is you can interchange any 2 rows anytime you want to. You can put the second row on the top. You can just switch rows anytime you want. Number 2, the one we're going to use the most, you can multiply the whole row. Well, you can multiply the whole row by any non-zero constant anytime you want to. If you want to multiply a whole row by 2, multiply by 2. You want to multiply by half, multiply by half. Anything you want to multiply a whole row by, you're allowed to do that. 3 is the one I was thinking about we're going to use the most. It says you can add a non-zero multiple of one row to another row, which means you can multiply one row by 2, add it to another row, and it becomes your new row. And that's what we're going to use a lot, and I'm about to show you our example, and it's a doozy, but this is what they're going to look like. So you really need to see it, and just hang in there. You're going to want to go like, oh my gosh, but just hang in there. It's going to be okay. Okay. Before I show it to you, our goal for an augmented matrix is to get it in row echelon form. And row echelon form was like this. If a row does not consist entirely of zeros and its first element is a 1, called a leading 1. So the first number we want in each row is a 1. For any 2 non-successive rows, the leading 1 in the lower row is first to the right, leading 1 in the higher row. Oh my gosh. And number 3, all the rows consisting entirely of zeros are at the bottom of the matrix. Okay. So this is what it would look like. This would be row echelon form. If you had something like this, 1, 2, 3, 5. Let's see, I have it. So I got 0, 1, 4, 7, and 0, 0, 1, 2. That is a row echelon form because the first number in each row is a 1, and each row as you go down the matrix, the 1 is further to the right than the one above it. That's row echelon form. Also says and this is going to happen sometimes. If you could row all of zeros, they need to be at the bottom. So if this were the case, that would still be row echelon form if everything's on the bottom. Now, there's one thing called reduced row echelon form, which means all you can have, it would look like this. If you can see the difference, it would look something like this. It would look just like that, where all you have on the left-hand side of my line there in the augmented matrix is 1 and zeros. And again, it looks like row echelon form, except all the numbers after the 1s are also zeros. This column over here, not that big a deal. That does not have to be zeros. Those are our constant terms, so those are okay to leave how they are. All right, so row echelon form looks like this. Reduced row echelon form looks like that. All right, here we go. All right. What they're going to do to you, they're going to give you a system like we've been doing, and they're just going to say solve it using an augmented matrix or a Gaussian or what's called Gauss-Jordan elimination. The only difference there is Gaussian puts it in row echelon form, and Gauss-Jordan puts it in reduced row echelon form. Okay, so I'm going to take, what I've done already is I've taken this system and put it inside my matrix. Okay, so that's all I've done so far. And because I know I want a 1, in my top left, I'm just going to switch my top row and my second row. That's a legal thing to do. So I'm going to use those rules I gave you earlier, those 3 rules to follow, and it's going to get crazy But I don't want you to hang in here and just watch this. The first time you see one of these, it really kind of like, oh my gosh. But the more you do them, like everything else we do, it starts getting a lot better. So hang in there. But I do want you to have one on video that you know that you have seen. Now, what I always do is this. I need a 0 right there, where that 2 is. What I try to do as much as I can is I'm going to use my top row to get rid of the numbers in the first column. So what I'm going to do is I'm going to multiply my top row by -2. Remember, one of my rules is you can multiply one row by something, add it to another row, and it becomes your new row. So I'm going to multiply the whole top row by -2. If I multiply the top row by -2, that becomes a -2, that's a +4, that's a +20, that's a +12. Now what I'm going to do with that is I'm going to come down here and I'm going to rewrite that matrix, except I'm going to change the second row. Okay, I'm going to add those yellow numbers on top to the green numbers in the second row. -2 plus 2 is 0, 4 and -1, 20 and 4, 12 and -3 is 9. All right, now, one more thing I'm allowed to do here. I'm just noticing this because look at my second row. I see a 0, a 3, a 24, and a 9. Another rule we had is you're allowed to multiply a row by anything you want to, anytime you want to. So what I'm going to do is multiply that whole row by 1/3, or really dividing it by 3. So 0 divided by 3 is 0, 3 divided by 3 is 1, 24 divided by 3 is 8, and 9 divided by 3 is 3. Okay, now if I'm looking at my second row, I really like it a lot because my 1 is further to the right than the 1 in the top row. So it's looking really good. Now, I'm going to do the exact same thing I just did, except I'm going to get rid of this 3 in my bottom row. And so what I'm going to do now is I'm going to use the top row again. I'm going to multiply my top row by -3 and add it to that bottom row. So I'm going to do 1 times -3, -2 times -3, -10 times -3, and -6 times -3. I'm going to add those numbers to my bottom row, the blue to the green. -3 and 3 is 0, 6 and 0, 30 and 4, and 18 and 7. All right, and I have that situation 6 and 34 and 25. Now this time they don't have anything in common, so I'm kind of stuck there. So I'm going to come on down, make another matrix. My top row I'm happy with for now. Second row I'm okay with for now. But the third row, what I want to happen is I need that 6. I need this 6 right here to become a 0. So I'm looking above the 6, and there's a 1 right there. So what I'm going to do is I'm going to multiply this second row right here by -6, everything in it by -6, to make that +6 go away. So if I do 0 times -6 is 0. 1 times -6 is -6. That's going to be -48, and that's going to be -18. And I'm going to add those green numbers to my yellow numbers on the bottom row. I get 0 plus 0, -6 and 6, -48 and 34 is -14, and -18 and 25 is 7. All right, so that's looking really good now. I'm gonna move this up a little bit. So what I'm gonna do is I need this number in my bottom row, that number -14, that needs to become a 1. So what I'm going to do is, remember, this is one of those steps you can do also. You're allowed to divide a whole row by anything you want to, or multiply a whole row by anything you want to. So I'm going to divide that whole bottom row by -14. That becomes a 1. And if I do -7 divided by -14, that's -0.5. So then I have 0, 1, 8, 3, 1, -2, -10, -6. All right, now, once I get there, guys, that is row echelon form. I just did Gaussian elimination. All right, so here's what I know for sure about my system. You can't see it anymore because I moved it, but my system's way up there. What I've found already is I know that Z is -1/2. All right, because of my bottom row right there. That's what that represents. So what I can do now is I can take that -1/2 and plug it right back in there, and I'll get 3x. If I do 4 times -1/2, it's -2 equals 7. If I move that 2 over, it's 9. Divide by 3. There's my x. So I know x is 3. I know z is -1/2. So what I'm going to do with those two is I'm going to plug them both in the top and then solve it for y. So I get 2 times 3 is 6 minus y. 4 times -1/2 is -2. So what I do is just plug that in. 6 minus 2 is 4. This negative 3. So get negative y is negative 7, or y is 7, guys. And there's my solution. My solution would be 3, 7, negative 1/2. And that's all you got to do. And I'm not saying that's all you got to do, like that's all you got to do. But we can actually go further than that, and we will actually tomorrow. I shouldn't have said that. Go a little further than that to solve it even more. But there you go. Gaussian elimination, matrices, solving systems with matrices. It's basically multiplying and adding, and we're going to get good at it tomorrow. So come ready to go. Don't give up. Don't ever give up. See you tomorrow.